Hey everyone, Mr. Keeney here again, here for geometry, and we're in our second section of units, or notes, excuse me, Unit 2, I got ahead of myself a little bit, Unit 2, Reasoning and Proof. So, in this unit, we are using deductive reasoning to form a logical argument. So when we're dealing with reasoning and proof, we're going to be dealing with more deductive reasoning. We talked about inductive and how it is patterns. Today we're going to be talking about deductive reasoning, but more about conditional statements. We're going to be working up towards if we can make correct and logical statements, conditional statements, we're going to get this if-then statement kind of situation where we can start moving forward in our arguments. But before we construct these big arguments themselves, we're going to be focusing on the statement. So that was me a lot of like throwing up some math terms at you. But basically, to sum it up, we were talking about logical statements today, and specifically a conditional statement. So the first thing I want to talk about is a conditional statement. A conditional statement is a logical statement that has two parts, and these are two things that I believe you have heard in the past. It has a hypothesis and a conclusion. Now, I believe this is something at least like in middle school science you've seen before. But in our statements here, every conditional statement will have a hypothesis and conclusion. And these will be written in if-then form. So if, and then our hypothesis, and then comma, then our conclusion. We're going to be writing those in this unit in that kind of situation, not the, then, there we go. And we use some notation to help us. Instead of writing if blank, comma, then blank, for hypothesis, you'll see people use P, and for conclusion, you'll see them use Q, just to label it. Doesn't matter what the hypothesis or conclusion are, it's just like a little notation. And so instead of saying if blank, comma, then blank, that just sounds weird, we will say, oh my goodness, we will say P, Q, or if P, then Q. That's probably how you're going to hear me say it the most. And there's that little notation up there that if P, then Q, P being, again, the hypothesis, Q being the conclusion. So when a conditional statement is written in if-then form, the if part contains the hypothesis, kind of like I was just saying, the hypothesis. Oh, typo. And this, again, we will call P. The then part contains the conclusion, just to reaffirm it in your brains. Hypothesis P, conclusion Q, and again, that P, Q notation. If P, then Q. Hypothesis, conclusion. So we can actually take definitions, just statements, and we can diagnose them between what is their hypothesis and what is their conclusion. So example 1 wants us to do just that. It says, if a polygon is a heptagon, then it has 7 sides. They want us to put the hypothesis and the conclusion. So here's the big kind of first thing that I think you will see on your test or test review, is that the hypothesis, I'm going to use one underline there, it does not include the word if. The hypothesis is a polygon, my spelling's lacking today, a polygon is a heptagon. It does not include the if. Similarly, if I were to look at my conclusion, it does not include the then. It is, it has 7 sides. So our hypothesis, conclusion, hypothesis again, P, conclusion Q. If a polygon is a heptagon, then it has 7 sides. Hypothesis, a polygon is a heptagon. Conclusion, it has 7 sides. So just breaking down the parts, we're going to do a little bit more practice as we go along with that as well. And then we have this fill-in-the-blank statement. The blank of a statement has the exact opposite meaning of the original statement, which we say the negation. The negation, which does have a little symbol, it's like a tilde or a little squiggly. That will mean negation. And example 2 wants us to go ahead and negate this. It says the statement is polygon ABCD is convex. So negation would be polygon ABCD is not, so there's that negation, is not convex. Another way we could have written this, because now that we've done Unit 1, instead of saying that it is not convex, we could have said polygon ABCD is concave, because we know if a polygon is not convex, it would be concave. So that would also be negating it if we wanted to get a little bit fancy. And again, we had that little tilde. That means negation. So kind of a lot there. To review what we've done, we have if-then statements, hypothesis, if hypothesis, then conclusion. Hypothesis is represented by P, conclusion is represented by Q, and negation gets us the exact opposite meaning of the original statement. So now a little practice of just identifying. They want us to single underline hypothesis and double underline conclusion. I'm going to reinforce it here that it does not include if. It does not include then. So for this first statement, if something is a US $50 bill, the hypothesis P is something is a US $50 bill. Then it has a picture of Grant on it, Grant being the president. Q, or our conclusion, it has a picture of Grant on it. So please, 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 if then is just structuring our conditional statement. Our conclusion, our hypothesis are kind of the guts that make it up. So if and then are not included. So if I go through here, I can see easily my hypothesis and conclusion. You'll see that they're kind of switching around if you were to read through these, which I don't want that to be the focus on this. But you'll see that they're just kind of switching around things, maybe negating things, and that has a purpose. I might go back to it later in a second once we get to our next page of notes. But here's kind of our hypothesis, our conclusion. Sometimes you'll see some like weird, bad grammar kind of thing. It says then and then if. And if you ever see that, they're trying to confuse you. The then part will always get the conclusion, and the if part will always get the hypothesis. So if they ever switch it up on you, make sure that you do not get fooled that it's the if that goes with the hypothesis, the then goes with the conclusion. It's not necessarily what comes first and what comes next, kind of thing. Okay, so we have 4 different statements. And we have talked about one so far. So the conditional statement is our original statement that we have talked about. Our original statement, if-then statement. You have not learned the other 3. So if you're thinking 4 statements, what the heck? You are fine. A conditional statement is our if, then, and we notate that as P, Q, if P, then Q. So what we're going to do with this conditional statement is that we can switch around, we can negate the hypothesis, conclusion, and we can come up with the converse, the inverse, and contrapositive. So taking these hypotheses and conclusions, like I said, we are going to create different types of statements. So for the converse, for example, it takes the original statement and it switches the hypothesis and conclusion. And by switching it, I literally mean it takes them and switches their spaces. So instead of saying if P, then Q, it takes the original statement and says if Q, then P. It switches them out. So if I were to look at something like up here, it says if something is not a US $50 bill, then it does not have a picture of Grant on it. It would switch those and actually say if it does not have a picture of Grant on it, then something is not a US $50 bill. You're going to see a lot of examples down below. The converse, it switches the hypothesis and conclusion. The inverse, what it does, it negates or takes the opposite meaning, negates the hypothesis and conclusion. So it does not switch them. It keeps if P then Q, but what it does is it negates the P. So if not P, then not Q, the negation of Q. And what we're going to find here is that these two, the converse and the inverse, while they're very different, one saying if Q then P, the other one saying if not P, then not Q, what we're actually going to find out is that these have the same truth value. And what I mean by that is if the converse is true, then the inverse will be true, or vice versa. If the inverse is true, then the converse will be true. Or if the converse is false, then the inverse must be false. But if we're saying whether the statements are true and false, the converse and the inverse will always have the same truth value. I'm going to switch back to blue, actually give me the same blue. And the contrapositive, you might be able to guess it. We've switched, we've negated. The contrapositive does both. It switches and negates the hypothesis and conclusion. So it takes PQ, and in all of these, the converse, inverse, contrapositive, when I say switches, hypothesis, conclusion, negates, it switches and negates, it's all based off the conditional original statement. So it takes that original PQ, it switches them, so it's going to have Q, it's going to have P, but it also negates it. So it says, if not Q, then not P. And maybe some of you guys were able to guess this, but these two will also, just like the converse and inverse, these two will have the same truth value, meaning if the original statement is true, then the contrapositive would be true. If the conditional statement is false, then the contrapositive will be false. So let's get looking at these actual real-life examples. Example 4, write the if-then form, the converse, the inverse, and the contrapositive of the conditional statement. Olympians are athletes. Decide whether each statement is true or false. So we're going to break this up. First, I say let's just write the original statement. The original statement, they want if-then form, and they give us Olympians are athletes. So we're going to say if you are, and I'm going to change the grammar a little bit. If you are an Olympian, then you are an athlete. And what we've got here is you are an Olympian is our P, and you are an athlete, period, is our Q. So the if-then form will always be if P, then Q. And we're going to go out and we're going to write, I'm going to change to purple here, we're going to write the converse, which that means we're going to switch them up. We're going to say if Q, then P. And after we're done with that, then we're at the inverse, which is negating the hypothesis and conclusion. And then we're going to do the contrapositive, which does both. It negates and switches. So if not Q, then not P. So we're going to go through, then we're going to determine the truth value. And remember, if it is false, based on our last section, if we say this is false, we're going to show it's false by giving a counterexample. So converse, it says if Q, then P. So if, and it starts with our original conclusion. If you are an athlete, then, and it's then it switches. So it's if P, which would be you are an Olympian. And some of these you might be able to tell right away if they're true or false. But like I said, we're going to come back at the end and say whether they're true or false. But I'm sure a lot of you guys have a good idea of some of these right off the bat. Okay, now the inverse. The inverse, again, we are going to negate. So we're going to take the opposite of the hypothesis. Then we're going to take the opposite of the conclusion. So if our original hypothesis was you are an Olympian, so we'll say if you are not an Olympian. Then, and we're going to negate the conclusion, you are not an athlete. All right, so again, we're just negating the P, we're negating the Q. So if you're not an Olympian, then you are not an athlete. Our last one, it takes the original statement, the if-then form, and it negates both of them, and it switches them. So we're going to say if, and we have to negate our original conclusion. If you are not an athlete, then it negates our original hypothesis, which is then you are not an Olympian. Okay, so we have written out in our first one, write out the original, the converse, the inverse, the contrapositive, and we have done so. We all based it on our original if-then form. Now we're going to go through and say whether they're true or false, and I want to remind you that the original and the contrapositive should have the same truth value, just as the inverse and the converse should have the same truth value. So let's take a look, see if Mr. Keeney was telling the truth. The if-then form says, if you're an Olympian, then you are an athlete. This is true for every single case. If you are an Olympian, Olympian is a very special type of athlete. It is the highest status of athlete you could probably get. So this is true. If you're an Olympian, you are a special subset of an athlete. So yes, if you're an Olympian, then you are an athlete. The converse. If you are an athlete, then you are an Olympian. I'm going to say this one is false, but I can't just say it's false. I have to provide a counterexample why this is not true. So if you're an athlete, then you're an Olympian. And my counterexample are going to be our Lee Summit North athletes. Our Lee Summit North athletes are awesome athletes, and they play a variety of sports, some of the multi-sports athletes, but they are not Olympians. They haven't reached that status yet. So false, this is not true. Our counterexample is our Lee Summit North athletes. They are not Olympians, but they're still an athlete. The inverse. If you are not an Olympian, then you are not an athlete. This is also false, and really, I'm going to use the same counterexample because I have to give at least one counterexample. I'm going to say Lee Summit North athletes again because they are not Olympians, but they are still athletes. So if you are not Olympian, yes, you can still be an athlete. Lee Summit North athletes is our counterexample. And notice that the converse and the inverse did have the same truth value. They were both false. We even used the same counterexample. And then the contrapositive, if you are not an athlete, then you are not an Olympian. That's going to be true. If you don't even compete in athletics, you are not going to be an Olympian. So notice that the if-then contrapositive, they are also the same truth value as well. So that ends our second section of notes. As far as where we're going, we're going to take a look a little bit more with these in a geometric worldview. So I will talk to you guys later. Thanks for watching.